This is the 8th video in my series on alternating current. In this video, we are going to take a closer look at phasors and how to describe them in a two-dimensional plane. More specifically, though, how to convert their description from one plane to the other. You'll find this topic along with others in my course entitled Basic Fundamentals of AC Circuit Analysis. You can access this and my other courses on my Stand Store at this web address. So we have seen that a phasor can be described in one of two ways. You can either use polar notation on a polar plane, such as we see here, or we can use rectangular notation, as you can see here. Notice that where we have not moved the vector or the phasor, it has remained in the same position. So you can uniquely describe a phasor in one of those two ways. So there must be a way of translating or converting rectangular notation to polar notation and polar notation back to rectangular notation. Converting from polar to rectangular and vice versa is a very simple process, and it can be demonstrated with this phasor here, and I've described it in both terms, both rectangular and polar form for convenience. So let's say we have the phasor in polar form, and we want to convert it to rectangular form. So that is, we have 5 at 36.87 degrees, and we want to convert it to a rectangular form. The real component of the polar form you can take by multiplying the polar magnitude by the cosine of the angle. So you take the magnitude 5 and cosine of 36.87, which is equal to 4, and that will give you the real component of the rectangular form. To find the imaginary side, you take the magnitude or the length of the magnitude of the phasor 5, and you multiply it by this time the sine of the angle, which is 36.87 degrees, and that equals 3. So that will give you the imaginary component, and you have to remember to put the J operator in front of it, of course, and whether it's plus or minus will fall out of the calculation. Now this time we want to go in the other direction. We want to change the rectangular form to the polar form. And you can find the polar magnitude through the use of the Pythagorean theorem. The polar magnitude is the hypotenuse of a right-angled triangle, and the real and the imaginary components are the adjacent and opposite sides respectively. So the length would be the square root of 4 squared plus 3 squared, which comes out to 5. And then to find the angle, all you have to do is take the arctan of the imaginary component divided by the real component, or 3 over 4. The arctangent of 3/4 is 36.87 degrees. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also, from time to time, be reviewing electrical products that, in my opinion, are worthy of paying attention to. This address will give you access to the supplier of the aforementioned type products. It is also a connection to obtain a free copy of my 24-page 3-phase transformer workbook, which will serve as a quick reference and reminder of technical calculations that you may need. This address, of course, is case sensitive. I'll spell it out and make sure that you have it right. Everything up to the first number is lowercase. That is lowercase https://bit.ly/3, then uppercase U, uppercase G, a lowercase j, uppercase B, uppercase I, and lowercase g. One of those amazing and versatile products is the 𝐃𝐈𝐒𝐂𝐋𝐀 Delta Pro Ultra, which can be modified to suit any homeowner's needs, operating virtually silent, and when paired with the 𝐃𝐈𝐒𝐂 Smart Home Panel 2 is extremely versatile. The 𝐃𝐈𝐒𝐂 Home Panel 2 ties any and all of your standby power equipment together and will control them efficiently. It will even control your connection to the utility grid to make sure you're only using the least expensive power, switching to your standby power during those expensive time of use rates. In order to view the full range of 𝐃𝐈𝐒𝐂's products and obtain a free copy of my three-phase transformer workbook, check into this web address and simply provide your email address, which will guide you to browse the full extent of their products. There is no cost or commitment for viewing, and by providing your email address, it will allow me to keep you posted on future videos, courses, and 𝐃𝐈𝐒𝐂 products.